Welcome to educator.com. This lesson is about writing expressions. In this lesson, you will learn to write algebraic expressions. Applications are for translating word problems into solvable equations. Let's look at the vocabulary. There are 4 operations that you'll be working with, and there are several verbal descriptions that are typical for the operation. Addition can be described as a number n plus 5. So the key word here would be plus. The sum of a number n and 5, sum, and 5 more than a number. 5 more than a number. Notice that more than is not saying 5 is greater than. It's not an inequality. In this case, more than is representing addition. All of these verbal descriptions could be written as n plus 5 or 5 plus n. It doesn't matter the order that you write it because in addition, order does not matter. Next, we'll look at subtraction. A number x minus 3. So here the keyword is minus. The difference of a number x and 3, the keyword is difference. And 3 less than the number x, less than. Notice once again, like before in addition, less than is not an inequality. Less than here is talking about subtraction. Unlike in addition, the order for subtraction does matter. So we need to write this in the correct order. X minus 3. This is also the difference of a number x and 3. And notice that the order here is a little different than the last one. 3 less than the number x. So what you're saying is 3 less than the number x here. So be very careful. That one is tricky, the wording with subtraction. It doesn't matter in the addition one because the order doesn't matter. But in subtraction, you have to be very careful with the order because that could change the value of the expression. Next, let's go to multiplication. 6 times the number y. Times is your keyword. The product of 6 and y. Product is your keyword. So in multiplication, the order doesn't matter either. However, in algebraic format, it's usually written with the number right next to the variable, so 6y, without any multiplication symbol in between. Lastly, we have division, a number t divided by 4. So your keyword is divided. And then the quotient of a number t and 4, quotient is your keyword. And that could be written 2 ways, t over 4, t divided by 4, that fraction line represents division, or you could say t divided by 4. But remember that in subtraction and division, the order does matter. So you want to make sure that you've written the variable and the number in the correct order. Translating words to expressions. Now let's try using that vocabulary in those verbal descriptions. Write an expression for the verbal description 9 less than twice a number. So we see the 9 and the twice, and there's a number. Twice represents 2 times, so we know that there's going to be some multiplication in there, and then we also see the word less than. So let's start with twice a number, because in order of operations, you would start with multiplication first. And now let's go 9 less than that, minus 9. And this is the correct order. It's 9 less than twice the number. So you want to have the 9 less than twice the number. So 2n minus 9. And a number, they don't tell us a variable that they want us to use. I chose n to represent number. A lot of people use x. That's fine. Any variable that you want to choose is going to be okay. Writing an algebraic expression. Now let's try to translate an algebraic expression from a word problem into something that we can solve. You go bowling and bowl 5 games. One game of bowling costs $5 and your shoe rental for the day is $4. Find the total cost. First, let's start with our algebraic expression. I'm going to use g for games. So games is represented by the variable g. So I'm bowling 5 games. That's 5 times g. That's the cost of games, is g. Or we should say the cost of 1 game since I'm doing times 5 here. And then there's a flat rate for the rental of $4. So here's my algebraic expression. $5 times the cost of a game, or 5 games times the cost of a game plus $4 for the shoes. So now let's plug in our $5 for each game. 5 times 5 is $25, plus the $4 for the shoes is a total of $29. So the total cost is $29. Joe is 26 years younger than his father. Write an expression using Joe's age to describe his father's age. If you have a hard time beginning a word problem and translating it into an algebraic expression, it's helpful to write out the characters of the problem. For example, in this problem, we have Joe and we have his father. And since the problem has asked us to use Joe's age to describe his father, we're just going to make it very simple that Joe is J years old. His father is older than him, of course, and since he's 26 years younger than his father must be 26 years older than him. So you take Joe's age and add 26 more years. So now we've written an expression to describe his father's age, J plus 26. And we used Joe's age as the base. Write an expression for the number of days in W weeks. Well, it might be hard to translate that directly into a variable, so sometimes you could create a table for yourself and see if you could find a pattern. So for example, if I said number of weeks and the total days. Well, we know in 1 week there's 7 days, in 2 weeks there's 14 days, in 3 weeks there's 21 days, 4 weeks there's 28 days. So if you notice, each time we're jumping an extra 7 days. And what we're doing actually is 1 times 7, 2 times 7, 3 times 7, 4 times 7. So we found our pattern here. Each time we're multiplying by 7. They don't tell us how many weeks, but they tell us that weeks are W. So what we're going to end up doing is W times 7. And if we're going to write that in algebraic form, it's going to be 7W. 4 brothers earn money by doing chores around the house. The brothers split the money equally. Write an expression to describe how much money each brother gets. Well, it doesn't tell us how much money the brothers get, so that's going to be our variable. I'm going to say that money is represented by M. So the brothers get a total of M dollars for doing chores, and they're going to split the money equally. So that means they're going to split the money 4 ways, and there are 4 brothers, so 4 ways. So M divided by 4. So here's an expression, or you could also say M divided by 4. Now, if the problem continues to tell you how much money the brothers make, you could just put it in place of the variable and divide by 4. Write an expression for the number of students S plus 5 teachers. So we don't know how many students there are, and that's going to be represented by our variable S. So we know that the number of students could change. For now, we're calling the students S. And then plus 5 teachers, so plus 5. And there's your expression. Thank you for watching educator.com.